Our objectives in this lesson are the following. Define linear equation in two variables. Determine the value of a, b, and c in ax plus by equals c. Evaluate linear equation in two variables. And model real-life situation using linear equation in two variables. But first, here are the answers in extra problems I gave in our previous lesson. Kindly write your score in the comments section below. Now, let's talk about linear equation in two variables. For those who have encountered this the first time, then there's no way to do it but to guess. Am I a linear equation in two variables or not? The first one is yes. The second one, no. The third one, no. The fourth one, yes. How about the fifth one? No. And the last one? No. Now, how come only 1 and 4 are linear equation in two variables? Here are the conditions for linear equation in two variables. Let's start at the bottom. No variable inside the radical symbol. I have here a radical symbol and there is a variable inside. So that's why this is an x. Next, no variable in the denominator. There is a denominator here and it contains a variable. That's why this is also x. Next, contains only one variable in each term. There are two variables in this term. That's why this is x. Next, each variable must be of the first degree. The degree of this variable is 2, not 1. That's why this is x. And it has two variables. Actually, all of this has two variables. Now, you already know how to determine if an equation is a linear equation in two variables. You might be confused. They may be written in different forms, like these three. This one is general form. This one is standard form. This one is slope-intercept form, which we are going to discuss in our succeeding lesson. But for today, we're going to focus our discussion on standard form of linear equation in two variables. It is an equation that can be written in the form ax plus by is equal to c, where a, b, and c are all real numbers, and a and b cannot be equal to 0. Otherwise, these two will be cancelled out and what you will be left is just a constant. And this constant is at the right side of the equation. Try this. Convert the following into a standard form. Again, let us recall the standard form. It is ax plus by equals c. Number 1. It's a rule of thumb that in mathematics, the first term should be positive. And our first term is x. So x here is already positive. Let's just copy it. And x and y must be together. So we have to move y on this side. And when we move it, it will become negative y. After moving y on this side, everything now is on this side. So we have to move positive 1 on the other side. And when we move it, it will become negative 1. So equals negative 1. Number 2, again, the first term, which is x, should be positive. So we have to move this negative x on the other side to make it positive. And then when we move x here, it is now together with 7y. So plus 7y. Again, everything is on this side. So let's move negative 4 on the other side. And it will become positive 4. Number 3, x here is already positive and it is with y, while the constant is isolated on the other side. So all we have to do is to exchange their position. So let's rewrite this as 3x plus 2y equals 9. Last one, number 4, x is already positive here. So let's copy it. X must be together with y. So let us move y on this side. It will become minus 5y. Our constant, negative 8, will be moved on the other side. It will become positive 8. Now let us add something into this. What if we determine the values of A, B, and C? Let's start with number 1. So our A is the coefficient of x, B is the coefficient of y, and C is the constant on the right side. So for number 1, our A is the invisible 1, our B is negative 1, and our C is negative 1. Number 2, our X is again invisible 1, our B is 7, and our C is positive 4. Number 3, our A is positive 3, our B is positive 2, and our C is positive 9. Last one, our A is 2 over 3, 2/3. Our B is negative 5, and our C is positive 8. So what did you notice? It is easier to determine the values of A, B, and C if it is written in standard form. So if your teacher asks you to determine the values of A, B, and C, make sure to convert them first into a standard form. Let's have another activity, satisfying linear equations. In our previous lesson, you have learned about ordered pair. What if you are asked to find an ordered pair that will satisfy a given equation? If this is the case, I'll give you a technique. The best way to do this is to let x be equal to 0. So I'm going to substitute 0 for x here. Let's do that. And 3 times 0, we know that it is 0. So we only have 2y is equal to 8. We need to solve for the value of y, so we need to eliminate this 2 here, and we can do that by dividing both sides by 2. So this 2 will cancel out, and 8 divided by 2 is equal to 4. So y is equal to 4. It means our ordered pair is 0 for x and 4 for y. This will satisfy the equation 3x plus 2y equals 8. Am I sure? Then let's do some checking. All we have to do is to substitute 0 for x and 4 for y. Let's do that. Are they equal? 3 times 0 is simply 0. And 2 times 4 is 8. Are they equal? Yes, they are. Therefore, the ordered pair 0, 4 will really satisfy the equation 3x plus 2y is equal to 8. But I have a question. Is this the only ordered pair that will satisfy this equation? No, let's have this activity. Give me more. Find 3 ordered pairs that will satisfy the equation x plus 6y equals 4. I have here table of values. This is the equation. And I already assigned values for x, negative 1, 0, and positive 1. Let me clarify this. You can assign any values for x. It's up to you. For me, I just want a representative for negative number, 0, and positive. So let me start. I'll copy first the equation given. I'll substitute negative 1 for x in here. And then this will move on the other side. It will become plus 1. 4 plus 1 is equal to 5. If I want to solve for the value of y, then I have to divide both sides by 6. So this will become y is equal to 5 over 6. It means the partner of negative 1 for x is 5 over 6 for y. Let's have the second one. Again, I'll copy the given equation. This time, I'll substitute 0 for x. So this will be disregarded. So I'll have 6y equals 4. And to solve for the value of y, I have to divide both sides by 6. So this will become y is equal to 4 over 6. In lowest term, both are divisible by 2. This is 2 over 3. So the partner of 0 for x is 2/3 for y. Let's have the last one. Again, I'll copy the given equation, and this time I will substitute 1 for x. I'll move 1 on the other side. It will become minus 1, and 4 minus 1 is 3. Again, to solve for y, let us divide both sides by 6. So this will become y is equal to 3 over 6. This can still be reduced to lowest term, and it is equal to 1/2. So the partner of 1 is 1/2. So the three ordered pairs that will satisfy this equation are, number 1, we have -1, comma 5 over 6. We have 0, comma 2/3. And we have 1, comma 1/2. Again, I repeat, these are not just the values of x that you can assign. You can assign any values of x that you want and then solve for the corresponding y values, and so you have your ordered pairs. What if we do it the other way around? Let's do extra challenge. Check each ordered pair if it is a solution of the equation x minus y equals -1. The ordered pair is a solution if it satisfies the equation, meaning the left side will be equal to the right side. So let us check if these ordered pairs are all solution of this equation. Let's copy our equation. Let us substitute -3 for x and -2 for y. Oh, be careful with this. Minus, so here is minus. And then your y is -2, so you have to enclose it in a parenthesis. Let us simplify this one first. Negative, negative will become positive. -3 plus 2 is -1. Are they equal? Yes, they are. Therefore, -3 comma -2 is a solution of x minus y equals -1. Let's have the next ordered pair. Again, let me copy the given equation. This time, I'll substitute 0 for x, -1 for y. Again, negative, negative, and then your y is -1. Negative, negative will become +1. And 0 plus 1 is 1. Are they equal? No, they are not. Therefore, 0 comma -1 is not a solution of x minus y equals -1. Let's have the last one. I'll copy again the given equation. I'll substitute 3 for x, 4 for y. So I have 3 minus 4 and that is equal to -1. Are they equal? Yes, they are. So it means 3 comma 4 is a solution of x minus y equals -1. Let's have another activity in the real world. Tonyo earns 90 pesos per hour for regular hours and 100 per hour for overtime hours. How much will he earn if he render 2 hours of overtime work after working 8 regular hours? So to answer this, let us let X be the regular hours while Y be the overtime working hour. And we are also given the following: 90 for regular working hour, 100 for overtime working hour. And if Tonyo works 8 regular hours and 2 hours of overtime, how much will he receive? So let's have our working equation for this. 90 times x, because 90 is for regular working hour and x is for the regular working hour, plus 100 times y, they are both pertaining to overtime working hour, is equal to the salary that Tonyo will receive. Tonyo worked for 8 hours regular time and 2 hours overtime. Let us substitute 8 for x and 2 for y. 90 times 8 is 720. 100 times 2 is 200. 720 plus 200 is 920. So this means Tonyo will earn 920 pesos after working 8 regular hours and rendering 2 hours overtime. For the summary, you have learned how to write linear equation in two variables in standard form, ax plus by equals c. And again, here are the conditions that you have to satisfy. Now, it is time to check your understanding. Pause this video for more time. Let us answer. Tell whether the following is a linear equation in two variables or not. Number 1, we have a denominator and there is a variable in the denominator, so this is not. Number 2, we have two variables in one term, so this is not. Number 3, we have two variables. Both are raised to the first power. No variable in the denominators, no variable in a radical symbol. So yes, this is a linear equation in two variables. Number 4, I have here a radical symbol and it contains a variable inside. So this is not a linear equation in two variables. Number 5, the exponent of the variable x is 2, not 1. So this is not. And last one, we have two variables here, and the exponents are both raised to the first power. No variables in the denominator, no radical symbol. So yes, this is a linear equation in two variables. Gets? Here are some extra problems for you to work on to master this lesson. Watch out for my next lesson where I reveal the answer. Our next lesson is finding slope given 2 points, equation, and graph.